Hello guys, welcome to Meka School. Today we are going to solve a trigonometric math problem, and it's an important question for Olympiad and entrance exam. The question is, prove that sec x equal 2 divided root over 2 plus root over 2 plus 2 cos 4x. We should start it from the right hand side, okay, not left hand side. If we start it from the left hand side, we couldn't find the original answer. We will find a lot of in general answer, okay, not this answer. So if we start it from that side, then we could easily find the sec x, that means left hand side. First of all, right hand side. So right hand side is 2 divided by 2 plus 2 cos 4x. First of all, we should write 2 plus. So from there, we can take common 2 from that two terms. If we take 2 as a common, then here remain 1 plus here will be remain cos 4x. Now root over 2 plus root over 2 1 plus cos 4x, we can write cos 2 times 2x. We have to know a trigonometric law. 2 cos square x equal 1 plus cos 2x. If we apply this law in our math problem, then we will find 2 divided 2 plus root over 2. So 1 plus cos 2 times 2x. Here 1 plus cos 2x means 2 cos square x. Okay. So here will be, replace that term, 2 times 2 cos square x. But here cos 2 times 2x, that means cos square 2x. Cos square 2x. Clear? Now 2 plus 2 times 2, that means 4 cos square 2x. 4 cos square 2x. 2 plus, we can write 4 as a 2 cos 2x whole square. Then we will find 2 plus, so here root and square cancel out, here remain only 2 cos 2x. So we can write 2 divided by root over, so from that two term we take common 2, so here remain 1 plus cos 2x. We know 2 cos square x equal 1 plus cos 2x. This is a basic law of trigonometry. Here remain 2, so 2, 1 plus cos 2x, 1 plus cos 2x, that means 2 cos square x, so 2 times 2 cos square x. 2 2 times 2, that means 4, 4 cos square x. So 4 cos square x we can write 2 cos x whole square. Okay, here remain only 2, root and square cancel out, here remain only 2 cos x, and 2 to cancel out, 1 by cos x. We know sec x equal 1 by cos x. So similarly 1 by cos x equal sec x, and this is left hand side, and it is proved. Subscribe our Meka School for getting like that maths problem.